Welcome to this short video on simulating infrastructure failures. In this lesson, we are going to explore the different types of infrastructure failures, including server crashes, resource exhaustion, and disk failures. We will discuss various techniques for injecting failures into servers, containers, and virtual machines to test system resilience. Additionally, we will review monitoring tools and strategies for responding to failures effectively. Let's get started. Simulating infrastructure failures involves intentionally introducing disruptions to critical infrastructure components, such as servers, networks, or databases, to test a system's resilience. This process helps to identify weaknesses, validate recovery strategies, and ensure continued operation under real-world failure scenarios. Infrastructure failures can be categorized into several types, including server crash, an unexpected failure of a server that can disrupt services and impact system availability. Here are the major causes of server crash. 1. Hardware failures. This occurs when physical components such as servers, storage devices, or network equipment malfunction, potentially leading to system downtime and data loss. 2. Kernel panics. A critical system error in an operating system's kernel that causes the system to stop functioning to prevent further damage. It typically results from hardware issues, corrupted system files, or incompatible software. 3. Software bugs. These are errors or flaws in a program's code that can cause unexpected behavior, crashes, or security vulnerabilities. Here are some common symptoms of server crash. 1. Inaccessibility. This occurs when users or systems are unable to access critical resources, such as applications, databases, or networks, due to failures or misconfigurations. 2. High downtime. This refers to prolonged periods when a system or service is unavailable, leading to disruptions in operations and potential financial losses. 3. Service disruptions. This occurs when a system or application experiences interruptions that affect its normal operation, potentially impacting users and business processes. Another infrastructure failure is resource exhaustion. The major causes of resource exhaustion are usually 1. Memory leaks. This occurs when a program fails to release unused memory, leading to gradual resource depletion and potential system slowdowns or crashes. 2. CPU spikes. This occurs when a system experiences sudden, temporary increases in processor usage, which can lead to performance degradation and slow response times. 3. Network saturation. Occurs when the demand for bandwidth exceeds the available capacity, leading to slow performance, packet loss, and service disruptions. The major symptoms of resource exhaustion includes 1. Slow responses. 2. Failed transactions. 3. System unresponsiveness. Another key infrastructure failures are disk failures. Here are the major causes of disk failures. Disk corruption. Occurs when data on a storage device becomes damaged or unreadable due to hardware failure, software issues, or improper shutdowns. Bad sectors and RAID failures. The symptoms are data loss, system crashes, degraded performance. Now let's look at the techniques for injecting failures. 1. Server failure injection. A method for shutting down critical services manually, using tools like Chaos Monkey to randomly terminate process A and inducing high CPU memory usage via load testing tools. 2. Container failure injection. A method for restarting containers unexpectedly using Docker commands, deploying faulty configurations via Kubernetes and simulating network failures with traffic control commands. 3. VM failure injection. This method is used for forcing reboots or shutdowns through hypervisors, simulating disk failures by detaching critical storage and creating artificial resource constraints using cloud provider policies. Next is observing system behavior and response. Once failures are injected, it is important to monitor system behavior and take corrective actions like using monitoring tools such as Prometheus and Grafana for tracking CPU, memory, and disk metrics. ELK Stack, Elasticsearch, Logstash, Kibana for analyzing logs and identifying failure patterns. Cloud monitoring services, such as AWS CloudWatch, Azure Monitor, and Google Cloud Operations. The key observations would be, to observe. How quickly do services recover? Are automated failover mechanisms working as expected? What alerts are triggered, and are they actionable? The best response strategies is to implement automated rollback mechanisms, improve incident response playbooks, and enhance observability for early warning signs. For recap, in this lesson, we explored the different types of infrastructure failures, including server crashes, resource exhaustion, and disk failures. We discussed various techniques for injecting failures into servers, containers, and virtual machines to test system resilience. Additionally, we reviewed monitoring tools and strategies for responding to failures effectively. Please note that you are required to take the quiz available for this lesson in the quiz section. In conclusion, simulating infrastructure failures helps teams build resilience and prepare for unexpected outages. Regular failure testing ensures systems remain reliable and responsive under pressure. Please click the link in the description to access this lesson on Motiva Logic Academy Learning Management System, where you'll find a quiz for every lesson, hands-on lab and projects to test and strengthen your understanding. While you're there, explore the full catalog of advanced hands-on courses and downloadable resources designed to help you move from theory to real-world expertise faster. Be sure to like, subscribe, share, and visit the link in the description. Don't forget to turn on notifications so you don't miss the future lessons. Thank you for watching.